Hello everyone, welcome back. Today we're doing lesson 1.4, number systems. So just from the previous lesson you will recall that the rational numbers are numbers that repeat or terminate, and most importantly can be written as fractions. Decimals that are non-repeating and non-terminating cannot be converted into fractions, and they're called irrational numbers. So when combining those two groups, rational numbers and irrational numbers, we get all the real numbers. So real numbers are the biggest category of numbers that we're going to be looking at, and it includes all the numbers, rational and irrational numbers together. But let's look at some smaller groups of numbers. And you might recall from previous math courses that the natural numbers are 1, 2, 3, 4, 5, and so on. There are no negatives in this group, and the zero is also not included. Okay, moving on to whole numbers. Whole numbers are similar to natural numbers, except this time the zero is included. However, we still don't have any negatives. Finally, when we get to integers, we include the negatives and positives and zero. Okay, but you'll notice in the first three here, there are no decimals in any of those three groups. Okay, finally, rational numbers. The best way to describe rational numbers is that you can write them, let me just go over here, you can write them as a fraction. For example, I can write 4 over 5, that's a rational number. So we're looking at any number a over any number b. As long as it's a fraction, it's a rational number. Okay, irrational numbers, they are, as I said before up here, they are non-terminating and non-repeating. Okay. This might be a little bit better in a diagram, and what we're going to look at, this is called a nested diagram, where each circle or square, in this case rectangle, is a nest of or a group of numbers. So the smallest category of numbers are the natural numbers. Okay, so that's the smallest group. Okay, so that's why they're in the smallest rectangle. Okay, the group above, the whole numbers, are similar, but they include the zero. But it's nonetheless a bigger group. Then we get integers, and we get the negatives in addition to the other two. So what you get here is that every group, or the next group that's bigger, has the numbers that are in the previous group plus some more additional numbers. Okay, and then finally the biggest box here, or the rectangle I should say, are the rational numbers. They can all be written as a fraction or a repeating decimal, but even a number like 3 can be written as 3 over 1. Therefore, it still qualifies as a natural number, a whole number, integer, and rational number. Okay, so any number can be written over 1. Okay, then over here we get a whole other group of irrational numbers, and they don't fit into any of these ones on the left here. And the key idea here is that they go on forever, so they're non-terminating. And then the big group here, the whole thing is what we call real numbers, and we can designate that by with an R, letter R. Okay. Okay. I should say there's a way to label these groups of numbers, and I forgot to do that. So I'm going to go back and hopefully this makes sense here. So the way we designate natural numbers over here is with the letter N. oops, that's a little bit way off there. Hopefully you can get that. That's the letter N. Whole numbers are W. Integers are I. So far so good. Every group is the letter that designates that group is the first letter of the word. However, things get a little bit confusing when we get to rational and irrational numbers. Rational numbers are written with a Q. They're described by the letter Q, and irrational numbers are the letter Q with a bar on top of it, like this. Okay, and I already said that the real numbers are R. So the only two tricky ones, I would say, are, these guys over here. So rational numbers again are Q, and irrational numbers are Q with a line on top of it. Okay, let's see what we have down here. Okay, so for each of the following, I'm over here, each of the following, write all the sets of numbers to which the given number belongs. Write the answer from the largest set to the smallest set. So right from the start, I'm just going to put an R next to all of these because I know they all belong to the real number set. Okay? And then I'm going to go from there. Okay, so now I ask myself, is the number rational or irrational? Well, for A over here, 9 is rational. So that again is a Q. Let me just go through all of these together when I describe the group here. So I'm going to do all of them for each category. So I'm going to do B now, and I can see that B is a fraction, so I know right away that it's a rational number. The square root of 5, when I put that into my calculator, I'm going to get a never-ending decimal, even though your calculator stops after, I think about 8 decimal places, but nonetheless it would keep going on forever. So that is an irrational number. So this one is done because there's no more subgroups of irrational numbers. Okay, -7 over here is a rational number. It can be written as a fraction, so I'm going to put a Q. Okay, my next group underneath that are integers. Okay, so integers, as we remember from up here. Okay, integers are these guys over here. So they're whole numbers, but negative and positive. so 9 would definitely work. So 9 is definitely an integer. Let's look at B over here. 11 over 7. Well, 11 over 7 is a decimal. We'll have a decimal, so that one is done as well. So it's not an integer. And if it's not an integer, it can't be a whole number or a natural number. So we're finished there. Okay, moving on to D. -7 is an integer. -7 is an integer. Okay, back to 9. And back to the next group. The next group is whole numbers, and whole numbers are 0, 1, 2, 3, 4, and so on. And this is clearly a whole number. So I'm going to put a W here. These guys are done. And -7, it's not a whole number because it's a negative number, and whole numbers are only positive. So those were done over here. Let's go back to the 9. Okay, is there any more subcategories? Well, yes, natural numbers are very similar to whole numbers, except there's no 0. But since we have a 9 here, that is okay. So 9 fits into the natural number set as well, and then we're done. There's no more subgroups. Okay. All right. Okay. Example number 2. It says explain why 9 belongs to 5 number sets, but -9 belongs to only 3 number sets. Well, the simplest explanation is that whole numbers and natural numbers, they don't have, you're not allowed to have any negative numbers in those sets of numbers. So -9 does not go into those two sets, natural or whole numbers, while the 9 belongs to those numbers, those sets as well. So that's the simplest explanation for that. Okay, moving on to square roots. We've kind of looked at this already a little bit. So all positive numbers have 2 square roots, a positive and a negative number. The positive square root is called the principal square root. Let's just talk a little bit about what this definition says. If I take 4 and I square it, I get 16. If I take negative 4 and square it, I'll put it in brackets there, I also get 16. So then the square root of 16 must equal positive or negative 4. Okay, so complete the following chart. Well, the perfect square of 1 over here is 1. The square root of 1 is plus or minus 1. If I go negative 1 times negative 1, I get 1. Okay, then I have 4, and I think we did this already for the first 15. But just what I want you to get out of this is that a negative number square also gives you a perfect square. Okay, so don't forget the negatives. Okay, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay. So the important thing with this table is that you memorize it. Okay, up to the first 15 numbers. This will make your life a little bit easier when it comes to tests and especially the provincial exam. So do your best to memorize the first 15 perfect squares. Okay? Okay, let's see if we can do the following. So example number 4. In each of the following estimate the value mentally to the nearest whole number. Then use a calculator to find the decimal approximation to one decimal place or the nearest tenth. Okay, the square root of 46. Well, I know that the square root of 49 is 7, so my best guess here would be 7. But when I put that into the calculator, I go square root of 46 gives me 6.78, and I'll just round that up to 6.8. So the answer is 6.8. The approximate answer, and I'll do a little squiggly equal sign, is 7. Okay, moving on over here, I have 2 times the square root of 18. Well, the square root of 18, the closest perfect square to 18 is 4. Is 16, I should say. 4 squared is 16. So the square root of 18, my best guess would be that it's 4. So I will go 2 times 4 plus 5 times, and now the square root of 37, well, the closest perfect square is 36, and the square root of 36 is 6. So that's my best estimation for the square root of 37. So I'm going to put a 6 here. And again, I'm going to put squiggly lines here because I'm not 100% accurate. So 2 times 4 is 8, and then 8 plus 30 is 38. Okay, so again, squiggly lines, 38. All right, now to do that on a calculator, we get 38.9. So our estimation, is not 100% accurate, but it's very close in this case. I'm only off by 0.9 here. Okay, so this one down here, example 4C, the square root of 5, well, the square root of 4 is the closest perfect square, which equals 2. So I just drop down the negative, so it's a negative. And when it's just a negative like this, it's really a negative 1 in front of there. So it's really a negative 1 times 2, and I get a negative 2 here. And the exact sorry, again, I should say with my squiggly lines here, because we're not 100% accurate on that one, we're estimating the square root of 5 times a negative is negative, put an equal sign here, negative 2.2. So not too far off, okay? All right, here we have a double square root, and don't get thrown off by this. It's just similar to brackets and following our BEDMAS. We start with the inside operations first. So I'm gonna drop the outside square root sign, and then I'm going to redo the inside one, and that's 95. Well, I'm going to just work with this inside bit right here first. So in that, I get again I got to look at memorize my mental use my mental math here to determine the closest perfect square, and the closest perfect square to 95 in this case is the square root of 100, and the square root of 100 is 10. So I'm going to just replace this over here with a 10. So now I have the big square root on the outside and just a 10 on the inside. Well, the square root of 10, and again I'll do my squiggly signs here, the square root of 10 is really the square root of 9, which is 3 if I had to estimate this. Okay, now your graphing calculator will allow you to do double square roots, so all I have to do is hit square root twice and put 95 in, and the real answer is 3.1. So again, I'm very close to the actual answer using my mental math skills. Okay. All right. Okay, we're going to skip this section over here. On to perfect cubes. Okay. So again, our perfect cubes. Okay, one cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, I think. 9 cubed is, what's 9 cubed? Let me do it here. 9 cubed, yes, 729. And then 1,000 for 10 cubed. You'll notice that the cube roots, the answers here are all positive, unlike the square roots. That's because when we cube a negative number, for example, if I go negative 2 cubed, I get negative 8, not positive 8, because negative 2 times negative 2 times negative 2 gives me negative times a negative is a positive, but then times another negative gives me a negative number. So we cannot use plus or minus for the cube roots. Okay, so we're going to do some more estimation for the first couple here, and I think we all get the hang of this, so I'm going to go through this pretty quickly. So notice how when I write the cube root, I need to put a little index of 3 here. Okay, well the cube root of 11, my closest guess would be with the cube root of 8 would be the closest whole number. So the cube root of 8 is 2. Therefore, the cube root of 11 is roughly 2. The cube root of 120 is going to be roughly 5, because the cube root of 125 is 5. The cube root, or now have a square root and a cube root in one question, so the square root of 70, the closest answer there would be, I guess, 8. 8 times 8 is 64, so I have 4 times 8 minus 4 times the cube root of 70. The closest number is the cube root of 64, so which is 4. So I'm going to put that as my closest estimate. So what do I get here? 4 times 8 is 32, minus 4 times 4, which is 16. So 32 minus 16 equals 16. So my answer is around 16. Okay. Thanks for watching. That'll be all for today. See you guys next time.